So guys, in this video, we are going to be learning motion in physics, and the aspect of it we are going to be focusing on is velocity time graph. So there are some terminologies we also need to know in this velocity time graph in order for us to be able to calculate and solve questions pertaining to the velocity time graph with ease. Now the first terminology is when they say object starting from rest. When you hear the word object starting from rest, it means that the initial speed that the object is using to move is what is zero. That's u. Initial speed or initial velocity is equal to 0 meter per second. That's the meaning of what object starting from rest. Acknowledge that. Now the second one is initial velocity. Initial velocity is the same as what starting speed. The speed an object use to start a motion is what we call initial velocity. So it's always represented with u. We use capital u, yes, we use u to represent it. So it's also known as starting speed or starting velocity due to the name initial. So final velocity is denoted with v, which is this one means finishing velocity. So finishing velocity or speed, whichever one. So that's what we call the final velocity. Now the next one we are going to focus on is the uniform acceleration. What is uniform acceleration? It means that when an object increases in equal amount of speed in the same time interval. You understand? When an object increases what? An object increases in speed, equal speed or velocity in equal time interval. So when that happens, when an object increases in equal speed in equal time interval, so that's what we call uniform acceleration. So the speed does not change, it's the same till it gets to a particular um, velocity. Now the next one is uniform or constant velocity. When you talk about uniform or constant velocity, is when an object increases in equal displacement in equal time interval. So, or you can also call it the time rate, the time rate of displacement. That's what we call uniform or constant velocity. And at this place, the object does not change its displacement with time. It doesn't change. It maintains equal displacement is the same as equal time interval. So time interval. So they have the same displacement in equal time interval. That's what uniform or constant velocity means. Now the next one is object coming to rest. When an object is coming to rest, in this idea, your v is equals to 0. That is, your final velocity is equal to 0. Final velocity is equal to 0 meter per second. That's what they mean by object coming to rest. Another one is total distance travel. When you are being asked to find total distance travel in a velocity time graph, we are concerned with the area under the graph. Area under the graph is our total distance travel. Area under the graph. So in other words, if we have a triangle, in the graph, like in the velocity time graph, we are going to use the formula for a triangle, which is half base times height. So this here will now serve anything we get as our answer to calculate the area of what triangle will serve as the total distance traveled by the object when experiencing a motion. So the next one is average speed. Now what is average speed? Average speed means that when a body moves in or when the body has total distance or the total distance of a motion, yes, total distance of a motion traveling over the total time taken. Do you understand? So total distance that the object used to travel over the total time it took the object to travel that motion. That's what we call what? Average speed. Don't forget, total distance traveled over total time taken is average speed. Now, what do we call acceleration gradient? Now, acceleration gradient is known to be like this: A equals to V2 minus V1 over T2 minus T1. So this is what we call acceleration gradient. Retardation, because this is the last terminology we are going to be focusing on. So retardation has to do with the decrease in velocity when an object is coming down or reducing its velocity. So that's what we call retardation. So it is the decrease in speed or velocity. That's what we call retardation. So the opposite of retardation, retardation is also known as deceleration, though. So it's another name for it. It is also known as deceleration. So have that at the back of your mind. And the opposite of it, the opposite of deceleration is acceleration. So is that noted, guys? So this is what we call retardation. For instance, if you have an example, maybe a speed of 10 meter per second is reduced to 5 meter per second. So this is an example of a retardation. So there's a decrease in speed from 10 to 5. You understand, guys? So now we have three equations of linear motion. So number one of it is v equals to u plus at. That's number one. Number two, we have v square equals to u square plus 2as. Then lastly, we have s equals to ut plus half at squared. So these are the three equations of motions that we have in to solve problems of velocity time graph. So of which the v here, let me identify all of these letters that we have here. Your v is final velocity, u is initial velocity, a is acceleration, t is time, s is distance. So these are the terminologies, these are the remaining of the letters that we have in the equations of linear motion. So acknowledge them. And now, after all of this, now we are going to be diving straight into the graph of velocity time graph. So we have a graph. This is velocity time graph. So this is the graph. So the graph usually look like this, where year would represent the velocity measured in meter per second. Year would represent the time measured in seconds. Note that the velocity time graph always writes your unit to not so as for you not to lose mark when you are writing your exam, because it's very important. The units are very important. So here you can now put 0, 0, which represents starting from origin. You understand? So now let me now use an illustration of what I mean by us using those terminologies to solve questions on velocity time graph. Now let's say I have an object moving like this, and like this. Now this movement here, starting from here now, going up. Now if they want to say an object is moving from this, it will start from here, then going up. Going up, it is changing velocity. Now this, the velocity is moving from 0 upward. So here would be known as acceleration. Here will be known as acceleration, which is measured in meter per second square. Then here, it is maintaining a constant speed or velocity, constant speed or uniform velocity. So it's maintaining it here. Then here, retardation. There is a retardation, that is, there is a decrease in the velocity. Here is acceleration. Retardation is also measured in meter per second square. It's just the opposite of acceleration. Now, total distance traveled. Look at the shape here. The total distance traveled is going to be the area of this shape, and this is the trapezium. So the trapezium formula, this is the trapezium here. The trapezium formula is area equals to half bracket a plus b close bracket h. You understand? So where here is the a, here is the b, and the distance from here to this place is known as the height when measuring a trapezium. So the total, the time taken now, the time it took it to move from here to this place is what we call time taking. So these are the terminologies that we need to identify when we are doing velocity time graph on the graph. And come to rest, when they say starting from rest is here, coming to rest is here. Do you understand? So when they say an object is coming to rest, and it's moving from here and it ends here, stops there, so our v is going to be 0. Now at this place our u is 0, our v is having a value here, but coming down our u is having a value and our v is equals to 0. So those are the things you need to identify in what, in velocity time graph. And with all of these things that I've just said, you should be good to go in solving questions on what, on velocity time graph. So we'll solve a question pertaining to velocity time graph. So now in this video we are going to be solving question pertaining to what, velocity time graph. So I just wrote out a question that will guide us on how to put it in a graph. Now question one says that, the question says that a bus moves from rest. You remember when I told you that when they say an object, you first of all draw your graph before you answer the question, then you indicate your v, then put your unit meter per second, then put the time second, then put your origins, it is 0, 0. So they now said a bus moves from rest, so it's going to start from here, from this place, and accelerated to a speed of 20 meter per second. So just take it up a bit, 20 meter per second. Let's just say 20 meter per second is here. So 20 meter per second. Now for 10 seconds, so you trace it back down, time, 10 seconds. Now say then accelerate to a speed, so it increased its speed again to 35. Now because it is increasing it, you have to indicate that it's moving in an increased speed like this. So this increased speed is 35, so that will be 35 here. So for the answer, it did that for 15 seconds. Now for the time aspect, you always add the times together. So 15 seconds, so 15 plus this 10 is going to accumulate to be 25. So 25. Now the next question says that it continues at a constant speed for another 70 seconds. So meaning it went straight another 70 seconds. So it didn't change the speed. It maintained that 35 meter per second for another 70 seconds. Do not forget, I said we are going to be adding the speeds together. So 70 plus 25 is going to give us 95. So 95 is the new time that will be accumulated here. So it now said, and finally comes to rest. If you remember when I said when an object comes to rest, your v is 0. So in 20 seconds, so that will be dragged down, managing the space, dragged down. Let me adjust it here. This is the t seconds. So coming to rest. So this space now coming to rest for 20 seconds. So 20 added to this is going to give 115 seconds altogether. So 115 seconds is what is going to be given. So now it is obvious this is now how the graph is meant to look like. This whole statement here, this is the graph. So if they now ask you further questions on it to do, like maybe find the total distance traveled. Now to find the total distance traveled, like I said, is the area under the graph. This is a triangle. You use the formula of a triangle, which is half base times height. This is a triangle plus, so you're adding it, triangle plus this shape now is a trapezium. So you find the area of a trapezium, which is half bracket a plus b close bracket h. So that's the trapezium. Then this one is a rectangle. So you add it to it, a rectangle, which is length times breadth. Then this one also is a triangle, which is half base times height. So you add it, triangle. So all the area of all these shapes that are in this particular velocity time graph is what will give us the total distance traveled. Yes, and let's say when we did this one, we had 90, we had 100, we had 200, we had 150. Assumption. So when you add all of them together, the value you will get when you add all of them together is your total distance traveled. So I think that has been explained to us. Then if you are solving further questions, because further questions will require us to use the three equations of motion that I told us in this video, where we had to do v equals to u plus 8e and blah blah blah. So there's going to be another video that we are going to do that is going to be what, only for questions under velocity time graph. We're going to be solving questions using the three equations of motion and the graph itself. So that's it. So that will be all for this video. And thank you very much. Do not forget, like, share and subscribe to this channel. Thank you very much.